All right. Welcome to Surrey Robotics Innovation Lab Workshop number 2 in part of the 2021 SRIL Gravity Car Challenge. We would like to begin by acknowledging that this presentation is being broadcasted from Surrey, British Columbia, Canada, located on the traditional and unceded territories of the Coast Salish peoples. Next slide, please, Daniel. That was the next slide. Next slide. Okay. So hello, I'm Clement, and on behalf of the entire Surrey Robotics Innovation Lab team, I would like to welcome everyone. We would also like to thank you for spending your Saturday afternoon with us, and we are excited to empower the use of CAD and 3D printing. Firstly, a little bit about Surrey Robotics Innovation Lab. We're an organization dedicated to empowering youth innovators through STEM. We host events like these every summer for hundreds of youth. Our partners include City of Surrey, Surrey Schools, UBC Centre for Community Engaged Learning, and SFU. We are incredibly grateful. Next slide, please. We're incredibly grateful for the UBC Centre for Community Engaged Learning for awarding us with the Connect Community Grant. Their support makes it possible for us to host events like these. At this moment, we're going to turn off the screen share for a little bit. At this moment, I would like to encourage everyone to turn their cameras on, smile at the camera, and say hi. We are going to be taking a group screenshot together, and we would love to see your face and your wonderful uniqueness come through the cameras. So at this moment, I would like to encourage you to turn on your cameras. There is a YouTube channel for SRIL in which these live streams will be posted, but we will most likely edit out the screenshot portion. You will not be in the YouTube video, so don't worry about that. Hello, everyone. I'm starting to see faces. Hooray! A few more. Okay, if you're not comfortable with turning on your camera, that is all right. We'll be taking the screenshot in 3 seconds. I'll count down from 3. Smile in 3, 2, 1. Cheese. Is that what people say nowadays? Cheese? Oh well. Excellent. At this moment, you may feel free to leave your camera on or turn it off. It is entirely your choice. And we will carry on with the presentation. Slides, Daniel. All right. Now I would like to encourage you all to give a hand for today's presenter, Daniel Louis, as you can see, controlling the slides. I would also like to say, let's also give you all a hand for participating in this event and making it possible. All right, Daniel, take it away. You got no audio, Daniel.
Sorry about that. I'm trying a new setup here. It doesn't seem to be working. You know what? I'm going to do something. I'm going to turn off my video for this workshop because I think that'll make everything so much easier. Right then. Okay. So yeah. So thank you for coming to this workshop. Most of you probably went to the last workshop. So we gave you a rundown of the Tinkercad and the basics of CAD and 3D printing. So thanks for coming to this workshop. And this workshop will be all about doing CAD with more advanced software. We're using Autodesk Inventor today, as you may recall me saying from last time. And we're going to get into the more technical aspects of how to get it working on a 3D printer as well. So we're going to get straight into modeling with an Inventor. So some of you may have already installed Autodesk Inventor just to try it out and check it out. But if you have, you can follow along. But if you haven't, don't worry. You can still watch, and we'll upload the slides, and you can of course try it for yourself after this workshop. So, right then, let's go straight into making a new part. So basically, when you want to make your gravity car design, what you are making is you are making a new part file. In CAD, there are part files, assembly files, drawing files, and mold designs. And what we're doing today is we're just going to make a part file. So if you open Autodesk Inventor, let me open this here. This is what Autodesk Inventor looks like when you first open it. It's your sort of start screen. And what you want to do is you want to click the button here that says new, and it'll open this window. And under templates, you can open this, you can keep expanding the folders here, bring it down to metric. And what you want to open is a standard millimeter file, right? You can also open an inch file if you want. That would be this. That would be in imperial units, but I think millimeter is easier for everyone to work with. So let's all use millimeter to standardize it. All right, so I'm going to create a millimeter part file. And this is your canvas, your blank canvas. You have nothing right here. Okay, so let me return to the slides. Where are slides? Here are slides. All right, so now we can look at the general interface of Autodesk Inventor, how to look around. So number one is the view cube, right? You would use the view cube to look around. And most of you have probably looked at Tinkercad already, and Tinkercad has the same view cube. So switching to Autodesk Inventor, it's this thing right here. This is the view cube, and you just drag it around like this to look around. Of course, right now it doesn't make a difference because we're just looking at air, right? We're looking at blank space, so it doesn't make a difference. But that's what you would use when you have a part and you want to look at different angles of it. Okay, what's next then? So on the left side, you have the model browser where you can see all your created features. So right when you start your part, you're not going to have any of this. You're just going to have your default things, and it's not going to do much. But as you make more things, you make extrusions, you make fillets, you're going to see more things fill up here. And this is where you keep track of all the different features you make. So then you might ask, what is a feature then? A feature is any object that is of interest. So a sketch, right? Maybe if you're to draw a circle, you could call that a feature. Maybe if you're to make that into a cylinder, you can call that a feature. Anything that is of importance, it'll show up on the left side as a feature. All right then. So if you look at the top menu, you'll see three main tabs. You see all the tabs, but the three main tabs that we are going to be using today is 3D model, and that's for editing your 3D features. But before you edit your 3D features, you're going to need to start 2D. So you're going to start with the sketch tab, which is for editing 2D features. And lastly, you won't use this as much, but you will use it. You will use the inspect tab to measure your model and make sure your model fits within the size limits, right? All right then. Let me switch back to Inventor and I'll show you where everything is. So on the left, you can see here, this was the model browser. Right here, I have nothing right now because I have not built anything. And up top, you can see 3D model with all your 3D tools, sketch for all your 2D tools, and inspect for all your measuring tools and also your tools to look at maybe the curvature of a surface or the stress or something like that. All right, then back to the slides. Next slide. Okay, let's go straight into sketching then. So everything needs to start with a sketch because you got to start with 2D before you can get to 3D in CAD, and that is the general rule of thumb. So you may click Start 2D Sketch to start a drawing, and that's this button right here. And then you may use the sketch tools to draw your sketch. So what does that translate into Autodesk Inventor? If we go here, you'll see the button here. It says Start 2D Sketch. So I'm going to click that. And it's going to present me with 3 planes: the XY plane, the XZ plane, and the the YZ plane. And typically you can probably start with the XY plane. It doesn't matter, but I'm just going to start with the XY plane. And you got your coordinate axis, right? You can see down here, left to right is X, and up and down is Y. So I'm going to draw a rectangle then. Rectangle to start my car body. And what dimensions do I want to make it? I'm just going to make it to the maximum dimensions. So that's 100 millimeters. Zoom out a bit. 100 millimeters by, how much was it? 50 millimeters. Right then. I just noticed something actually. This might be relevant to you. If you installed Inventor and you looked around, you might have noticed that when you try to zoom out by scrolling the mouse wheel downward, you're actually zooming in. And when you want to zoom in, you're zooming out. So that's kind of a weird quirk. And I can show you how to fix that right now. If you go to File and you click Options, and then you can go to let's see here. Hardware prompts, gotta be somewhere here. Oh, right here. If you go to display, you can go zoom behavior and reverse direction and click apply, click those, and that makes your zoom more intuitive, because I think typically people would expect when you scroll the wheel down, you zoom out, and when you scroll the wheel up, you zoom in. So so that's how you do that. Anyway. All right, back to the slides then. So you can see here I have made my rectangle, right? And it's oh, sorry about that. That should be 40. It shouldn't it be? There we go, 40. All right, 100 by 40, and that's just a regular rectangle. All right then, so that's what that looks like then. So after I make a 2D sketch, I want to make it 3D now, right? So what I can do is I can finish the sketch by clicking Finish Sketch, and I can click the extrude button right here to turn my 2D profile into a 3D feature. So back to here, I will click Finish Sketch. And as I click Finish Sketch, you will see I have now Sketch 1 on here. And if I hover my mouse over it, it highlights it. So that's my first feature. But I want to turn that into 3D, right? So I'm going to click Extrude, right? And it's going to select that sketch feature profile. And I'm going to extrude it by 50 millimeters, right? So down here, distance A, you can enter whatever number you want, right? I can enter 9,000, and it's going to be a super long extrusion. But 50 is the limit of our car design, right? So I'm going to put 50, and up here you can like flip it. You can make it go both ways. You can do that, right? To make it go however much distance in one way and another distance in another way. But this is your basic extrusion, which is 50 millimeters in this way. So I'm going to click OK. And there we go. I got a box now. And if you look on the left side on the model browser, you can see the Sketch 1 has disappeared. That's because Sketch 1 has been used in the process of creating Extrusion 1. If I click the plus here, I can expand this list, and you can see Sketch 1 is now a part of Extrusion 1, right? We had Sketch, and we evolved it into an extrusion. All right, back to the slides then. Yep. All right. How to edit an existing feature. So a lot of times when you finish a part, you will want to edit that part, or you want to change, maybe you want to make the extrusion longer, or you want to make it shorter. So how you do that is you double click on a feature in the model browser, and you will enter the settings for it. So let's say I want to edit extrusion 1, because remember I extruded it by 15 millimeters. Let's say I want to edit it. Let's say I want to make it 30 millimeters. So I would just double click it, and I could just go straight back into the settings, right? So all you do is just you double click it. And if I want to go to the sketch, I just double click the sketch, and I can edit the sketch. And when you click finish, it'll update. But I'm not going to change it because I like how it is now. And of course, you have this end of part thing that you see at the very bottom. End of part is basically where you want to cut off the program from rendering your features. So right now, end of part is below everything, which means it is fully rendering everything. So you can see everything I've done. I haven't done much. I just made a cube or a parallelepiped. But if I want to not see what I just made, I can drag the end of part upward over here. And well, I have gone back to a state of time where I have made nothing, right? So right now it's not a very useful thing to use. Right now it's not a very useful thing to use, but say you have more things in the future and you want to see what it looks like at an earlier time, it can kind of be helpful. Okay, moving on. Putting text on a surface then. Okay, before I do that, I suppose I should maybe make this look more like a car, right? So I'm going to now use all of our previous knowledge to show everyone how to make a car sort of shape out of this box sort of shape. So what I can do is I can start a 2D sketch on any surface that I've already made. And I'm just going to start it on this surface right here. Okay, and now I'm drawing on this plane. So first, I guess I want to make holes for the wheels, right? Let's say I want to make hubs so the wheels are recessed into the car body, right? Maybe that's more aerodynamic, right? So what I'm going to do is I'm going to use the line tool to sort of help guide me along to get me precise locations where I want to make holes. So let's say I want to make the center of a hole, let's say 5 millimeters from the bottom. So I would go on the line here. I would go 5 millimeters up. I would enter 5, press enter. Oh, that did not work. Let me try again. I want to go 5 millimeters. Oh, that is not working. Well, that worked. Okay, anyway, well, yeah, okay, well, that is, well, I just drew a line going up. If you want to change it, you can always press the dimension button here. You click this, and I want to make it 5, right? So there we go. We have a 5 millimeter line going upward. And that can help us place our circle like this. And remember that the wheel is 30 millimeters in diameter, so I want to give it some clearance. So I'm going to say, let's say 33 millimeter wide circle, right? And lastly, I want to make it sort of like a car hub for a wheel, right? So I want it to be straight down here. So I can go here. This is tangent to the circle. I can go straight down like that, right? This is tangent to the circle. I'll do the same thing on this side like that, right? And now what I want to retain is I want to retain this outside part, right? So I can delete what I drew before. I'll delete the circle. Not yet, actually, not yet. Before I delete circle, I want to make an arc. So I'll use the arc tool. I click first point, I click second point, I draw up, I match it with the circle, and now I have an arc tool. So behind the circle is this wheel hub, right? So if I delete the circle, which I will do right now, delete, I now have this hub for the wheel. And I don't really have to delete that. I'll keep that for now, I guess. All right, so I have one hub for the wheel. Now I'm going to do the same thing. So I'm going to go over here somewhere. I'm going to create a 33 millimeter diameter circle. I'm going to take a line, draw down there, take a line, draw down here, take an arc, complete that hub, right? And delete the circle, which helped us earlier, but we don't need it anymore, so we're going to delete it. All right, now we have these two wheel hubs, and these, oh, wait, we are not done actually. We are not done. We have to close this profile. like that. Okay, now we are done that. And we're going to close this profile like that. Okay, so we have closed the profile. These are fully closed sketches because when you extrude, you need closed sketches, right? So now they're closed, I can select them. So I'm going to select this one, I'm going to select this one, but instead of extruding outward, I want it to go inside of the car's body, right? So what I'm going to do is I'm going to click this to flip direction. I'm going to make it, so if you recall, the wheel's thickness is 9 millimeters. So I'm going to give it a bit of clearance. I'm going to say 11 millimeters deep into the car body. So I put 11 there, it's going inside, and it is cutting into the car body. So I'm going to click OK, and there we go. We have now wheel hubs where the wheels will go. So if you imagine, there will be a wheel right there, and there will be a wheel right there. Okay, but next, we still need holes for the axles, right? We need 2.2 millimeter holes for the axles. So we're going to do, once again, we're going to click Start Sketch. We're going to click any of these faces, okay? And do you know why we click any of these faces? We don't want to click this face, because if we click this face, we are going to be drawing, on air, like we're going to be drawing like in this like blank area. We want to draw on here, right? So I'm going to click any of these faces. I'm just going to click this face. And I'm gonna use my line tool again to help me guide where I want it to go. So let's see here. You can see it sort of snaps like there. There we go. I've got a 5 millimeter line. Okay, and you can use that to give you a point of reference. 5 millimeters from the bottom. I want to have a 2.2 millimeters circle. So 2.2 millimeters. I'm going to enter that in right now. 2.2. Put enter. And I'm going to do the same on this side, guide myself down there, 2.2 millimeters, enter. And we don't really need that line. You can keep it. If you don't want to keep it, you can delete it. Doesn't really matter. And I can click Finish Sketch. So now we're going to do the same, right? We want to make 2 holes going through the car body. So I'm going to use the Extrude tool again, very important tool, Extrude. I'm going to click this. I'm going to click that. And I want it to go inside of the car. So I'm going to click flip, and I want it to go through the entire thing. So instead of entering a distance, I can go to the right here. It's going to say through all. So if I click through all, it now makes the axle through the entire body of the car. Okay. And while you're making this, if you were to make this, or if I were to take my time making this, I would be making the hubs on this side as well, because of course we want wheels on this side as well, right? But for the sake of time, just for this demonstration, I'm just going to focus everything on one side. But really, I would just do the exact same thing to this side as well. It's just all symmetrical, right? All right. So now we have our very, 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 very basic car shape, right? I mean, if you wanted to make a car like this, you could enter this into the race, right? This is kind of all you kind of need to make, because it got wheels and you got axles, right? That's kind of all you need to do. But we want to make it more fancy, right? So going to the slides again, putting text on a surface then. So as you know, the rules are everyone wants, we want everyone to have a team name on their car. So what you would do is you would start a new sketch on a surface and use the text tool to write words. And then you would exit the sketch and use the extrude tool to make it 3D. So the first part might be a little bit new to us. So, first part might be a little bit new to us. So I'll show you how to do that. So you're going to click Start New Sketch, and I'm going to click this face right here. You can click any face, whatever face you want to put it, except for the bottom, of course, because we don't. Why would we want to put words on the bottom of a car, right? So I'm going to click this face, and I'm going to click this here, text, and draw an arbitrary box somewhere here, and it opens this window to enter your text. So what I can enter is Cool Boy 2.0, right? This is our upgraded version from our Cool Boy 1.0 from last workshop. And important things to note when you're in this window, this box right here is basically your font size. So where in maybe like an email or Microsoft Word or something like that, you will have maybe like 12-point font, 3-point font. Those are based on pixels. What we are looking at here, because this is an industrial CAD software, we're looking at millimeters. So this tells you the height of your font. So right now it's kind of too short for us, right? If I click OK, you will see that the height is like 3.5 millimeters, right? So I'm going to double click this text, double click. I want to make it taller. So I'm going to select the text. I'm going to make it 8 because I think 8 is reasonable. And then I click OK. And now the text is 8 millimeters tall. All right. And there's also another thing that I want to show you guys, which is this box right here. It's the stretch percentage. If you enter a percentage less than 100, you can squish your text. So if I put 80 and I click OK, it gets squished. If I put 120 and I click OK, it gets elongated, and you get like this elongated one, right? And of course, 100 is your standard proportional text. Okay, finish sketch. Back to the slides then. Planes. Next up is planes. So a lot of the times you might want to draw a sketch that is not on an existing surface, because so far we have just been drawing sketches on surfaces that we already extruded, on surfaces that we already made, right? So maybe you want to make a floating sketch, right? This sketch is like it's in the air, it's floating above the surface of this car, right? So what we're going to do is we're going to navigate to this plane button. We're going to click the drop down menu, and offset from plane will allow us to do this. And there are other ones that you may explore, like parallel, mid plane, right? But offset is what I find to be the most useful. So I'm going to go here. I'm going to click plane here, offset from plane, and the top surface here. And I can offset it by however I want, right? What should I put then? What looks good? 25 maybe? Sure, 25. All right, now I just made a plane 25 millimeters above the surface of the car. Now, of course, if I were to draw above it, I would be exceeding the size limit. So do keep that in mind, but this is just for demonstration purposes. So on your model browser, you can now see work plane 1, right? So now if you go start 2D sketch, you, instead of selecting a face here, you can select this plane here. And we are now drawing a sketch in the air floating above the car. So what should I draw then? Let's draw a rectangle. I'm going to draw a rectangle, right? I don't know, that looks good, I guess. And I click finish sketch, and you can see that there's a rectangle floating above my car now. And once you're done with the plane, if you want to get rid of it because it does kind of obstruct your view of your actual model, you can right click the plane in the model browser, and you can uncheck visibility, and you'll get rid of the plane and just see what you drew. All right. All right, then moving on, you have lofting. So lofting is what you would use when you want to create a smooth transitional shape between two sketches. So you can see in the picture here, I have a rectangle that I drew. And let's say I want to make like sort of a fin, right? Or like a rudder, or like, you see these kinds of things on maybe ships, right? Or maybe on airplanes. Maybe this is more aerodynamic, right? Or maybe it's just for style. Let's say I want to make something like that, a fin or something like that. What I would do is first I would draw the starting sketch profile, right? And then I would draw the ending sketch profile, which I may need a plane for. And you can see here, I did make a plane with the rectangle, and then I can use the loft tool. So I'm going to show you how to use the loft tool. But before I can do that, I need to first create that first sketch that I was talking about. So I need a first rectangle. So I'm just going to draw one right there. That looks about right. That looks all right. And now I can click loft, which is right here. Okay, I'm going to click loft, and I'm going to select one face, and then I'm going to select the second face, and it's going to automatically make a nice smooth transitional shape in that transitions from this large rectangle to the small rectangle, right? So if I click OK, I got this nice fin looking thing, right? Very aesthetic. If I right click work plane and I right click and I uncheck visibility, you can see your model in its full glory, right? You got this random fin looking cool thing here. Okay, then, so that's how you would use the loft tool. Going back to the slides then. Next is sweep. So sweep is what you would use to make a sketch follow a path while it is being extruded. So you can see here, I want the extrusion to follow this sort of lightning bolt path. And what I would do is I would make a plane in the center of the car. It cuts through the center of the car, and I draw it up like that. And then I draw another face on the top of the car, and you would use sweep to sweep it up like that, right? So I'm going to show you how to do that then. Oops. Back to Autodesk Inventor, I'm first going to get rid of this. I'm going to suppress it like that because I don't want to see it anymore. I'm going to go here like that. I'm going to draw a rectangle again. It doesn't have to be a rectangle, it can be a circle, it can be any shape you want, but I'm going to draw a rectangle like that, and it's on the roof of the car. And now I need a plane. So I'm going to click offset from plane, and I'm going to want to offset from this face because I want it going into the car like that, right? So I'm going to click this. I want it to go like that. And I know that my car is 50 millimeters wide. So if I go -25, it's going to put me straight in the center, right? So there, I now got a plane in the center of the car. And you can make this plane bigger if you want. It doesn't actually affect anything at all, but it just makes it easier to visualize, I guess. And then I'm going to click Start 2D Sketch on this plane. All right. And I'm going to draw a line from the center of this square. Okay, so line tool right there, right? Where is it going to be? Like that. Okay, I'm going to draw a random. Okay, I don't know what a lightning bolt really looks like, but that I guess looks kind of like it. I'm going to draw that. And as you can see, now we got a line coming from our rectangle. If I click, where is it? If I click sweep, it's going to let me select this, and then it's going to let me select that, right? And then I can click OK. And then I now have this fancy lightning bolts sticking out randomly from the top of my car, right? So once again, because this is a little bit complex, I want to explain it a little bit more. What you would do is first you would select the base profile, so that's your square, and secondly you would select your line right there. So I'm going to redo it because this is kind of important. I'm going to redo it for you guys here. I'm going to click sweep. It says select profiles first, so you can click it. You can click this here, it should be automatically selected, and you click that, and then you can click the second one to let the program know that you are now selecting the path that you want to take, right? And then you select the path, and then you click OK, and you got your lightning bolt. So that is how you use sweep, and sweep is probably the most complex tool that we'll be going over today. And of course, now that I'm done with the plane, I don't really want to see it because it's blocking my view of my glorious car. So I'm gonna unvisible it. So now I can't see it. All right. So if I re-enable my loft, you can see it's right there, right? This is what a loft looks like. Loft is face. You got one face down here, one face down here. You got another face down here. and you're creating a smooth 3D feature between the two faces. And if you look at sweep is you got a surface and you want to extrude it, but you don't want to extrude it just straight, right? You want to extrude it in a nice fancy path like that. So that's why you would use sweep, right? So that's the difference between loft and sweep. Okay, moving back to the slides then. Now we have fillet and chamfer. So fillet and chamfer are sort of things that you would apply to your car after you're done after you're done the core design. So you don't really want to add fillets when you're in the middle of designing because it could interfere with because CAD likes sharp edges, right? So if you make fillets, you might mess up some of the planes that you might want to create in the future. So so after you're done making a model, you can sort of round things out using a fillet, which will round out an edge. As you see in this picture, you got a sharp edge and you are rounding it out. Or you could use chamfer, which is sort of like fillet. But it creates a transitional surface at an edge. And you might wonder what that means. So I'm going to show you, of course, right here. All right, but I guess before I do that, I want to sort of make it look more like a car with this windshield. So I'm just going to make a quick windshield right here. So going back to our most basics of using Autodesk Inventor, I would start a 2D sketch on this surface, like I've done many times. I'm going to draw using a line like this, right? Let's see what looks good. I guess that looks good, right? Drew a line there. I'm going to draw a line down to here, right? And then I'm going to draw a final line connecting it, because remember, you must have a closed sketch. So I'm going to close up the sketch by doing that. And now we have a closed triangle. Okay, going to finish sketch, we now have a triangle at our car here at the front. And we want to extrude it like that. We want to extrude it the other way, and we want to extrude it through the entire car. So we click through all. And boom, we got a windshield in front of our minivan, or whatever this car looks like, right? I mean, it's a minivan with a lightning bolt on top, so I guess it's a very fancy one. And now I can show you the fillet tool. So fillet is right here, and chamfer is its neighbor right there. So I'm going to show you fillet first. Fillet will round out your edges. So if you click here, right, it automatically sets it as 2 millimeters, but I can make it more, right? I can make it 5 maybe, right? And you got a nice rounded edge right there. And let's say this one, let's say I want to round out this one. What I would do is I would click that edge there, and I'll round it out. Let's say a 10 millimeter fillet. And as you can see, it creates a round surface, nice and round. All right. So now I'm going to show you chamfer. Chamfer is kind of like fillet, but instead of rounding, it creates like a sharp transitional surface. And let me undo everything, and I'm going to replace my fillets with chamfers. So I'm going to click here. 2 millimeter chamfer. Okay, sure. And as you can see, instead of making a rounded surface, it just makes a straight surface, right? So there's a subtle difference there, but there will be a bigger difference if I apply it to here. So I'm going to click chamfer. I'm going to click this edge. And as you can see, let me make it bigger. Let me make it, I don't know, 5 millimeters. There we go. As you can see, it creates a transitional surface. So instead of going from here straight to here, it creates a middle surface that goes like that, and then it goes like that. So it is less of a sharp edge, but it's not round like it would if you were to use the fillet tool, right? All right, then back to the slides. And now this is a slide where I can give you the full rundown of the car. So I'm gonna open up a model that I made before this workshop. So let me save this one, I guess. Why not? Real quick. And let me open the one that I made before. So this is the car that I made prior to this workshop, and it has basically everything except it also has the other side. So I did the wheel hubs on the other side as well. I decided to use fillets here and there to round things out. I kept the lightning bolts. Yeah, it is of course outside of dimensions, so it's just for demonstration purposes. So this is what the car looks like, and I'm gonna do a quick recap of everything that we went over. So on the left side, you have the model browser. You have all your features here. You have the main body, wheel sockets, windshield, axle holes, wheel sockets 2, which is the other side, as you can see. You got team name, fillet 1, 2, 3, and work plane 2 that is invisible. Work plane 3 that is invisible. We have a loft that is invisible. Let's say I wanted to change my sweep to a loft. I can always unsuppress it. And boom, now I have this. And if you want to double click into something, let's say I want to change, the wheel sockets, right? I double click into the wheel sockets. Let's say I want to make it only 10 millimeters. Then I can do that. I change it and I made it 10 millimeters deep now. End of part. I guess now is a good place to show you the end of part. The use of end of part. So if I want to see my car at an earlier stage, let's say I wanted to see what it looked like before I added any of the fillets, I can drag it up here. And this is what my car looks like before I added any fillets, right? Because it is not rendering anything that I made after, right? All right then. So once again, a 3D model is where you do all of your 3D. The 3D model is basically everything you see on here. And if you were to expand everything under each 3D feature, you would see the 2D features, which is right here, right? You got your sketches, right? Which are comprised of lines, circles, arcs, rectangles, and of course text, because you need to use the text thing to create the team name. And lastly, before you submit the file to us, you probably want to measure it to make sure everything fits within the size limits. So I can go here to inspect, I click measure, and I can say, let's say, how wide is our car? I can click just this line, any line really. I can click this line and it'll say 50 millimeters. So great, it is within dimensions, within the limits, right? Let's say I want to see how long this bottom is, right? Let's see here. I would click from, oops, that is not what I want to do. I will click from here to around there, and that's 99.416 millimeters. Yeah, that's around 100 millimeters, so that looks good. That's within dimensions. And let's see how tall it is. So we can say, let's ignore this. Let's suppress it, because if I were to actually submit this to print, I wouldn't be putting that. Suppress. All right, if I were to measure the tallness, the height of this car, I would click this length here, and it says 40 millimeters. So yeah, so this car is fully printable, fully submittable and printable, and it is within the rules. So let's go back to the slides then. Now I want to show you how to save it as an STL file, because you can't just put a CAD file into a 3D printer and expect it to print. You first have to save it into a compatible file system. So how are you going to do that in Autodesk Inventor is you're going to navigate to the file button. You're going to press save copy as. Then you can click file type here and save it as an STL. And you will click the options button. And the options button will bring up a window here. And you have to set units to millimeters. That is very important, because if you set it to like inches or something, then your model might be massive and it might be out of the limits, right? And you can set your resolution to high, and that's all you need to do. And then you can click OK and continue saving. So now I'm going to show you how to do that. I'm going to show you how to do that in real time then. So from file, I go save as, I go save copy as. Now it's going to open the save as window, save copy as window. I need to select, instead of the default IPT, I need to select STL, which is down here. I need to click options. I have to make sure it's millimeters, so this is wrong, right? this will automatically went to centimeters, which is not what we want because we want millimeters. So I click that and I click resolution high, I click OK, and then I click save. So I have just saved my model car, my gravity car, as a file that I can send off to the 3D printer. But we can't 3D print it yet. We first have to slice it. So let's go over slicing then. So slicing is what you have to do before you put it into the 3D printer, because the 3D printer can't just take a model and it can't just automatically figure out what ways and what layers, how fast, what flow rate to extrude the plastic at. It has to be given to it very explicitly in very simple terms. So what a slicer does is it takes a model, it takes your settings such as your speed, your infill, how much supports you want to put on it, and the overhang angle, for example, and it puts it into very basic movements for the 3D printer. It puts it into the most basic commands like move nozzle to coordinate 1,2. Next, move coordinate into coordinates, move nozzle to coordinate 2,3, and it just does that. It exports everything into the most simplest commands for the 3D printer, right? So so a slicer converts the model into instructions can follow. It provides information such as the print time, the mass, length of the filament required, and the cost, and allows you to adjust print settings such as speed, layer thickness, and supports, right? Okay, so so you guys won't be needing to do this because we are printing it for you. But of course, this is still a workshop on 3D printing, so I still want to teach you what it's like to use a 3D printer slicing program, right? So what we'll be using is Cura, and Cura is a widely used slicer that works with a variety of printers. And as you can see here, this is just a screenshot, and we have our model here that we exported as an STL, and then we imported into Cura. And you can see our model here, but you may also see it has 2 extra blocks down here, which may look a little bit weird because we didn't make that in our model, right? And that's because these are supports. Because you see, even 3D printers are affected by gravity, right? If we have a hole here and a 3D printer is trying to print in layers like that, once it reaches this layer, it's because the printer is in that sort of liquidy form, it's gonna like sag down, it's gonna fall instead of making one smooth line. So what we need to do is we need to enable supports, and the printer will automatically print 2 blocks right here, which will act as temporary parts of the object that will make it so that when the printer comes to this layer to print that line, it will successfully print that straight line across. And what you can do after it's done printing is you can just you can just use your fingernails or something like a X-Acto knife or something, and you can just break off the support. Okay, it's really easy to break it off because the slicer prints it not as dense up here, so you can stick a knife in there and just pry it off. And that's how supports work. Things to keep in mind when you're printing, because 3D printers are they're not they're not perfect, and they're not invincible. They're not capable of printing anything you want in however orientation you want. So I just want to give you guys all some design guidelines to make your prints more successful. And these are just guidelines. You don't have to follow them if you don't want, but these are just guidelines. Try not to have really small features. And that's because printers, just like 3D printers, just like 2D printers, they have a resolution. They print in layers of 0.2 millimeters thick. So if you make something that is too small, the printer won't be able to print it clearly. It might look like a blob once it comes out, right? So just try not to make anything that is too small. And that mostly comes down to words, because words are usually pretty small things. So make sure you don't use too small words or anything like that, or symbols or anything. Next, every cantilever will need a support. And you might ask, what is a cantilever? A cantilever is just a right angle. If you see, I'm going to go back a slide here. If you look here, you sort of see this right angle here. I guess this part is what you can kind of call a cantilever. And basically, if I just printed this part here, you would need a support, right? And that's exactly why the support is there, because we just have to put a support there. Otherwise, the print will just sag down and fall, right? Oops. Third, try to have at least one flat side. And this just makes your print more reliable. It makes your print more successful. Because if you have one flat side, then if you have one flat side, then we can lay it flat on the print bed, right? So this side of the car, the side of the car that is on the bed, it is flat. So there's no bumps or anything. And that just makes it more of a successful print, because there will be no problems with it. Maybe, maybe coming unstuck from the bed or anything like that, because it's just fully flat, right? And lastly, text only has to be 1 to 2 millimeters deep to be easily visible. And this is sort of just advice. You don't have to follow it. If you want to make, like text that pops out, that's perfectly fine. But it's just some advice that this text right here, it is already very prominent, and it's only, I think, 1 millimeter deep into the car, right? So just some guidelines to help you out. And I guess I can also show you how it works in real time. So where's my Cura? Let me open it up right here. So this is what it looks like, right? I would click import, right? I would select the model, which I already have, which is right here. We have our cool boy, and on here we have our settings, right? So we can select the layer height. I have selected 0.2 millimeters high. Infill density is 10%. Print speed is 150 millimeters per second. And I want to generate supports, because if I don't generate supports, this area right here will fall to the will fall. It'll fall out of the model. So what I'm gonna do is I'm gonna 1 second. Is I can click slice down here. So if I click slice, it computes everything, and it says it will print in 3 hours and 4 minutes. So I guess that gives you an idea of how long it takes to print something like this. It'll take 45 grams of filament, which is 15.6 meters. So it gives you an idea of how much filament it'll use if you are maybe low on filament or something like that. And you can go to this tab right here, the preview tab, and I'll give you in a color-coded fashion what filament, what line is what type. So you can see here, this color means it's a support. This red color means it is an outline to make the general outline of the car. And this middle color in here is the filling, to fill in the car itself, right? So that's a rundown of what a slicing software is. So what I would do is I would click save to disk. It would save it as a G file, a .g code file, which is just a very basic rudimentary motions that a 3D printer will go through, and it'll execute it step after step. All right, then back to the slides. Right, so improvements to the gravity car challenge. So we got some emails from you guys in the past week after the first workshop, and some of you guys said, well, maybe the dimensions are not reasonable. Maybe it would be more favorable if we could have a longer dimension for the length. Maybe we could, instead of having 10 centimeters for the length, maybe we could go longer, right? So I just want to open this floor up to everyone. If you could use the annotate tool right now. Let's see here, how do I enable that? Oh, it should be enabled. So everyone, please use your annotate tool. If you have any ideas, just let us know. if you have any ideas or anything, and I'll just read the chat right now to see if anyone has questions.
So how this is going to work is we are planning to ask you guys, the participants, to see if you are interested in increasing the build dimensions of length from 10 centimeters to 14 centimeters. So the way that we would prefer that you respond is using the annotate feature. If you could either stamp a check mark for yes or an X for no to whether you want it bigger. If you play a check mark, you want the bigger one. If you want to keep the rules as is, please put an X. Whoa, one check mark per person, please. It looks like it's still an overwhelming yes, because the only X is my demonstration. Okay.
Oh, nice.
So with that, we will update your build size. The build size will now be 140 millimeters long by 50 wide by 40 tall. So if we look into the chat, I will write down the updated size. All right, you guys have more space to work with. And I'm going to turn off annotate again. Where in the world is the off button? Wait, Daniel, I can't turn it off.
Oh, it's okay. Let me do that for you. All right.
Okay, I can clear it.
All right. Yeah, thanks for your input, guys. I mean, this workshop is this summer event is we want to make it fun for all of you guys. So thank you for your input. Now let me see if I can remove annotations.
All right. So I would like to clarify a few questions that there were in the chat as we were going.
Yeah, go ahead.
One of them is, can we have 3 wheels? This came up last time, but we didn't get to answering it. So the axles can only attach to one side of the wheel. In order to have a 3-wheeled vehicle, you'd probably have to put an axle through one of the wheels. That unfortunately is not possible. So we ask that you have a vehicle with 4 wheels, please. In regard to the controlling infill density, the entire G code in the slicer process will be done by SRIL. You do not need to slice it yourself. We'll be controlling the infill and whatnot just to keep a level playing field, because these cars are about your creativity. So while yes, we would encourage you to figure out how to make cars more dense in areas and different locations, controlling the infill with G code is not one of them, unfortunately. As we mentioned earlier, depending on time constraints, your cars will be printed at a set infill of either 10% or 15%.
What we'll get you to do is when you submit your designs to us, it'll be a Google form, just like the ones you've been filling out so far. And we'll get you to submit your CAD file itself, so the .ipt file. And we'll get you to also submit the .stl file, which is the one that we would use in the slicer. And that's because we can have a backup to fall back on if your STL doesn't work, because maybe the slicer won't be able to print some parts of the STL because of the way you modeled it. So we'll open up your .ipt file or your Autodesk Inventor file. We'll take a look and maybe make some revisions so that it will print successfully.
Can you make an empty bubble of air in the car? That might be a difficult one. Yes, you can make an empty bubble inside of your car. It's just going to be very annoying for us to clear out the support material. So yes, we encourage you to be creative, but just remember that if you make an empty bubble that's completely enclosed in the car, it's likely good to get filled up by support material. or
Yeah.
it's just going to be filled with random garble from the 3D printer, because
Yeah.
empty bubbles generally aren't what the printer likes doing. The support material is less dense than walls, but it can still add substantial amounts of filament to the car, depending on the open space. In terms of team selection, Daniel, do you have any?
Yeah, yep. So we have not yet sent out like a formal email for team selections yet, and that's simply because we still have space. So what that means is if you registered a team, that basically means you're in because we still have space, right? So we're not gonna say, oh, I'm sorry, we rejected your team because there's not enough space or anything like that. So basically, if you registered or you and your team registered, then you pretty much know for sure that you're in.
All right. And for the 20th team, since there's one more slot, feel free to apply into that 20th slot. There's just one remaining. Now, if you are, let's say there's a team here that hasn't registered and the 20th slot is gone, we still encourage you to apply, since if a team is unsuccessful in producing a car, there will be a waiting list just in case a team is not capable of presenting a car. So don't lose hope. There is always hope. And who knows, maybe if we have extra time, maybe we'll have an extra team. But we're going to see that there's no guarantee that there will be more than 20 teams. As of now, the 20 team limit is still in effect, but we'll try our best to get everyone involved as best we can. Can we inset the wheels of the car? I believe that means like putting them in fenders and whatnot. Yes, you can inset the wheels of the car. That is perfectly fine. As you saw with Cool Boy 2.0, the wheels were inset inside of the car, so works perfectly fine. Can we get the link for the team selection? Because I'm not sure if our team is registered or not.
Okay, so Clay, I just looked at the registration form, the race registration form right now, and we actually went up to 23 responses. So we will be looking at those responses. Unfortunately, it does seem that we are over the limit now, which means not everyone will actually get a slot. Basically, if you registered before today, like you got in, because before today it was at 19. But we will send an email. We will. Oh, it went up to 24 just now. What do you know? Yeah, but we will send an email out with the final confirmation of the list of people who have gotten a team slot. Maybe try to give us 1 or 2 days to finalize the list, and we'll send it out as soon as possible. All right, Andrew?
In the case that you do not get in, don't be discouraged. We still fully encourage you to design your car. We will try once again to see if we can get it into the competition and whatnot. But unfortunately, because there are limited slots and limited materials, this year we are a little bit short or on the team slots, and we hope to improve as we grow as an organization. Must the draft design be sent in to register? No, you do not have to have a draft design during your registration. But in the registration page, if you've already looked at it, it will have a few questions on how do you plan to accomplish your goals. This is how we will be deciding which teams get to compete. The more teams that have more of a set plan on how they're going to design their car, like chassis designed in 1 week, aerodynamics another week, or something like that, a team that's well planned and well organized is more likely to enter the competition. But again, we will try our best to be unbiased and select teams and participants equally as best we can. Well, the time is actually now 3:06 p.m. So the workshop is actually over at the moment, but we will definitely be here for any questions that you may have. Again, we thank you for showing up. you are free to go and you are free to stay. We'll be here for the next few moments.
Yep, thank you for the awesome questions, and thank you for the comment there, Edina. That means a lot to me. Yeah, if you have any more questions, feel free to stay. Clea and I will be happy to answer them. And we look forward to seeing you in the next workshop. And I wish you all good luck in designing your cars.
You're very much welcome to everyone that said thank you.
Mm-hmm.